Today's topic is higher order linear differential equation with constant coefficients when we need to find the particular integral when the q of x value is when q of x is to when q of x is equals to e to the power of ax into some v of x, e to the power of ax into v of x. So this is the method we are going to learn in this session. So my name is Dr. K.V. Vidyasagar, lecturer in mathematics, SVLNS Government Degree College, Bhivanpatnam. So before going to the problem session, first of all, I want to give some brief introduction about the method or procedure when the q of x is equals is in the form of e power ax into v of ax. First of all, the procedure to compute the particular integral when the given equation f of d into y is equals to q of x and q is equals to x power k. Step 1, write f of d is in the form of d power some m into 1 plus psi of d. F of d is equals to d power m into 1 plus psi of d, where c is some constant and d power m is the least power of d in f of d. And step 2, expand the y plus psi d to the power of minus 1 and consider only those terms that contain d square d to the power of k. And after that, apply the operators to the x to the power of k and neglect the terms where the derivative or nth derivative or kth derivative or n minus kth derivative of x power k is 0. So by this way we will find the particular integral. So for this we need to know some formulas, 1 plus phi of d to the power of n and phi of d to the power of minus n, 1 plus phi of d to the power of plus 2, 1 plus phi of d to the power of minus 2, 1 minus phi of d to the power of minus 2. Next, procedure to compute the particular integral of f of d into y is equals to q of x. In this method, first of all, 1 by f of d into e to the power of I, f of d into e to the power of ax into v of x is equals to e to the power of ax into 1 by f of d plus a into v. After that, you may find by using the formulas 1 by d or 1 by d minus alpha into q of x or 1 by d plus alpha into q of x or 1 by f of d when q of x is of e to the power of ax or 1 by f of d when q of x is in the form of sin ax or cos ax and so on. So this is the third method when in unit 4 when f of d into y is equals to q of x is equals to x into v where v is some function x. For this the formula is 1 by 1 by f of d into x into v is equals to x into 1 by f of d into v minus 1 by f of d into f dash delta d into 1 by f of d. Problem number 1. So given problem, let us suppose the given problem is d square minus f of d into f of d plus 6 into y equals to x into e to the power of 4x. So this is the equation which is in the form of f of d into y is equals to q of x. It means that this given equation is a higher order linear differential equation with the constant coefficients, where f of d is equal to square minus 5d plus 6 and q of x is equals to x into e to the power of 4x. Then the corresponding auxiliary equation is f of m equals to 0, that is m square minus m square minus 5m plus 6 equals to 0. Therefore, the correspondings are 2 and 3. The roots are real and distinct. Then the complementary function is c1 e to the power of 2x plus c2 e to the power of 3x. Now, the main part of this problem, particular integral. Particular integral formula is 1 by f of d plus q of x. 1 by f of d is, f of d value is d square minus 5d plus 6. And q of x is equal to x into e to the power of 4x. So already I explained how to find the when the q of x is equal to e power x into v, then e power x should come forward, and in place of d we need to write d plus a into v of x. So by using that methodology, by using that procedure, so it is equals to d e power 4x is here, and 1 by, in place of d I will write d plus 4. So d plus 4 whole square minus 5 into d plus 4 plus 6 into x, the remaining value in e power 4x come forward, and v of x value x. So this is equal to e power 4x by 1 by doing d plus plus 4 square is equal to d square plus 16 plus 8d minus 5d minus 20 plus 6. D square value is d square, 8d minus 5d plus 3d, 16 plus 6, 22, 22 minus 20 is 2. So this is the remaining value after doing some simplification. So e power 4x, I will 2 has common, 1 plus 3d plus d square by 2 into x. So therefore this is equals to e to the power of 4x by 2 plus 1 plus 3d plus d square by 2 e to the power of minus 1. So this is in the form of 1 plus x to the power of minus 1. 1 plus x to the power of minus 1. 1 plus x to the power of minus 1. What is the formula for 1 plus x to the power of 1? 1 plus x to the power of minus 1 is 1 plus x to the power of minus 1 is equals to 1 minus x plus x square minus x cube plus x to the power of 4 and so forth. By using this formula, so 1 plus x to the power of minus 1 is 1 minus x. After that 1 minus x plus x square, but x square derivative of x is 1. Derivative of x is 1, and second derivative of x is equals to 0. So after that all the remaining all derivatives are 0. So I would like to take only first derivative of x. So from second, third term onwards, I will neglect all the remaining terms. So 1 minus 3d, 3 by 2 into x, the derivative of x is 2. So 1, so x minus 3 by 2, that e to the power of 4x into 2x minus 3 by 4. This is the particular integral. So the complete solution or the general solution is y is equals to plus yp. Y is equal to yc plus complementary function plus particular integral. So y is equal to c1 e to the power of 2x plus c2 e to the power of, this is complementary function value, and the particular integral value e to the power of 4x into 2x minus 3 by 4. Now second problem. The given equation is in operator form is f of d into y equals to q of x. So d square minus 6d plus 13 into y is equals to 8 into e to the power. This is known as operator form. So d operator form is f of d into y is equals to q of x, and f of d is here, f of d value is d square minus 6d plus 13, and q of x value is 8 into e to the power of 3x into sine 2x. The auxiliary equation is m square minus 6m plus 13. M square plus 6m plus 13 is equals to, this implies that the roots are 3 plus 2a. After doing this by using the formula minus b plus or minus root over b square minus 4ac by 2a, the roots are 3 plus 2a. So the complex conjugate roots. When the complex conjugate roots, the complementary function is e to the power of alpha x into c1 cos beta x plus c2 sin 2 beta x. So complementary function value is e to the power of 3x into c1 cos 2x plus c2 sin. Now the particular integral is 1 by f of d into q of x. 8 is constant, so 1 by d square minus 6d plus 13 into e to the power of 3x into sin tx. So e to the power 3x come forward, and in place of d I will write d plus 3. So 1 by d plus 3 whole square minus 6 into d plus 3 plus 13 into sin 2x. So this is equals to 8 into e to the power d square 6d minus 6d is 0, and then 9 minus 9 is 0, and 3 square is 9, 6 3s are 18, total value is 4, total value is so sin 2x. So in place of d I need to write minus 4, minus 4 plus 4 is 0. So I will use the for this I use the formula x by f dash delta d square into sin 2x. So x by d square plus 4 derivative is 2d, d square plus 2. So 8 e to the power 3x into x by f dash delta d is 2d sin 2x. 2d sin 2x means sin 2x derivative is cos 2x by 2. So minus cos 2x by 2, so minus x2 by 2 into cos 2x. So the general solution is complementary function plus particular integral. So complementary function is y is equal, this is complementary function e to the power 3x into c1 cos 2x plus sin c2 sin 2x. Complementary function is minus 4 times 2 2s are 4, 4 2s are, sorry, 4 2s are. So 2 e to the power of 3x into cos 2x. 2x e to the power 3x cos 2x. So this is the required solution for this one. Next problem number 3, d square minus 4d plus 3d plus 3 into y is equals 2x e to the power 3x plus 3 e to the power. So auxiliary equation is m square minus 4m plus 3 equals 0. It implies that m minus 1 into m minus 3 is equal to, so the rule and distinct. Therefore the complementary function is c1 e to the power of x plus c2 e to the power of 3x. Now the particular integral value is 1 by f of d into q of x. Q of x value is 2x e to the power 3x plus 3 e to the power of x into cos 2x. So I will divide in the terms into two terms. So 2 into 1 by d square minus 4d plus 3 into x e to the power 3x. Similarly 3 into 1 by d square minus 4d plus 3 into e to the power of x into cos 2x. So this equals to e to the power 3x come forward. So 2 into e to the power 3x by, in place of d I will write d plus 3 whole square minus 4 into d plus 3 into e to the power of 3x into e to the power 3x plus 3 into e to the power of x into 1 by d plus 1 whole square minus 4 into d plus, sorry here 4 into plus 3, this is equals 3 into x. So in this second term 3 into e to the power of x into 1 by d plus 1 whole square minus 4 into d plus 1 plus 3 into cos 2x. So the first term 2 into e to the power of 3x by 1 by d square d terms is 2d, and here is 3 plus minus 12, 9 plus 3 12, 12 minus 12 0. So d square plus 2d into x plus 3 into e to the power of x into 1 by d square minus 2d into cos 2x. Now e to the power 3x into 1 by d e to the power 3x into 2d common. So 2d common, 1 plus d by 2 into, therefore here in place of d square I will write minus a square minus 2 square minus 2d cos 2x. So e to the power 3x into 1 by d into 1 plus d by 2 to the power of minus 1 into x minus 3 by 2 into e to the power of x by 1 by d plus 2 into cos 2x. So it is in the form of 1 plus x to the power of minus 1. So 1 minus x plus x square and so on into x minus 3 by 2 into e to the power of x by d plus 2 here. Numerator and denominator I will multiply with d minus 2, d minus 2 by d square minus 4 into cos 2x. So e to the power 3x into 1 by d minus 1 by 2 d plus 4 and so on. So integration of x is x square by 2 d to the power of x into sin 2x plus cos 2x. Now the general solution is complementary function plus particular integral complementary function value is c1 e to the power of x into c2 e to the power of x, and the particular integral value is x square minus x by 2 into e to the power 3x minus 3 by 8 into e to the power of x into sin 2x plus cos 2x. Problem number 4. Given equation is, let us given with d square minus 4d plus 4 into y equals x square sin hx plus e to the power of 2x plus 3. So auxiliary equation is m square minus 4m plus 4 equals 0. So the roots are real and equal. So the corresponding complementary function is c1 plus c2x into e to the power of 2x. Particular integral value is 1 by d square minus 4d plus 4 into x square sin hx plus e to the power of x plus 3. I will divide this term into 3 terms. So 1 by d minus 2 whole square into x square sin hx value is e power x minus e to the power of minus x by 2 plus 1 by d minus 2 whole square into e to the power of 2x. Similarly, the last term is 1 by d minus 2 whole square into 3. So it is equals to e to the power of x by e to the power of x come forward, and in place of d I will write d plus 1. D plus 1 minus 1 is d minus 1. So d plus 1 minus 2 is d minus 1. So d minus 1 whole square into x square. So in this, and also e to the power minus x into 1 by d minus 3 whole square into x square. And the third term x square by 2 into by 2, since when we replace d in d with 2 it is 0, when x by derivative also 0. So x square by second derivative of d minus 2 whole square is 2 into e to the power of 2x, and the third, and the 3 is gone 3 by 4. So 3 by 4. Now e to the power of x by d minus 1 can be written as 1 minus d to the power of minus 2 into x square, and minus e to the power of minus x by x square, 3 square, 3, 9, 9 2s are 18, 1 by d minus 3 whole square to the power of minus 2, and plus x square by 2 into e to the power of 2x plus 3 by 4. Now e to the power of x by 2, the expansion is 1 plus 2d plus 3d square and so on and so forth into x square minus e to the power of minus x by 1 plus x square plus 7 and so forth. So 1 plus 2d by 3 plus 3c square by 9 plus and so on and so forth into x square, and the last two terms are remain same, x square by 2 into e to the power of 2x plus 3 by 4. Now e to the power of x by 2 into 1 into x square, 2d of x square is 4x, 3d square of x square is 6, minus 16 into minus 6 into, so 1 into x square, and 2d of 2d by 3 is x, this is d square, 4 by 3 into x square plus x square by 2 into e to the power of 2x plus 3 by 4. So this is the particular integral. So the general solution is phi c plus y is equals to yc plus yp. So y is equals to yc value c1 plus c2x into e to the power of 2x plus particular integral value is e to the power of x by 2 into e to the power of 2x plus 3 by 4x square plus 4x plus 9 minus e to the power of minus x by 18 into x square plus 4 by 3 into x plus 2 by 3 plus last two terms are x square by 2 into e to the power of 2x plus 3 by 4. Thank you.